Hi everyone. So let's start today's session. Seeing no more people here. Yeah. Let me share the screen first.
Good evening, sir.
Hi Deepa. Yes, I have some questions. You want to ask something?
No, sir.
Okay.
Actually, I couldn't attend last 2-3 sessions.
All right.
So, but last time I scored full. I mean, 100 on 100, sir, in last assignment.
Oh, nice. Yeah. But you are you understanding what I am
Yes, sir.
tutoring?
Actually, numerical methods. I have. Actually, I'm teaching numerical methods also, so it is not very difficult for me. But
Okay.
last time I faced difficulties, so then I watched this. These recorded videos. So it helped me a lot.
Okay, that's good. Okay, I will start. My voice is muted. Okay, so last time we have seen the Simpson rule and trapezoidal rule. So this time we are going to see composite Simpson's rule and composite trapezoidal rule, and some questions over that, and Simpson's rule. Okay, so first of all, what is composite trapezoidal rule? So if you are given some function f, then you are given some points x naught x1, the value of function is f naught f1 at these points, then you somehow measures this difference, which is given by the integration from x naught to x1, fx dx is approximated by f naught plus f1 divided by 2 into x1 minus x naught, right? So that's kind of trapezoidal rule. So in this one, you have only 2 points, x naught and x1. But if you look at this one here, so this is called as composite. It means you are integrating over several points. Okay, so I'm just going to write that over here. Okay, so if you have to find the integration, suppose from 0 to 1 fx dx, and h is given to you as 0.2. H is the step size. So like you must first make the grid 0, 0.2, 0.4, 0.6, 0.8, and 1, right? So this is your f, and you have several values of f at these points basically. Then what does composite means is just you need to apply the trapezoidal rule over here, here, and here, and here. So you need to apply the trapezoidal rule over all the segments. And from there, you have to find the formula for that. So it's just easy as simple. So what is the integration? I can write it as 0 to 0.2 fx dx plus 0.2 to 0.4 fx dx and up to 0.821. Okay. So 0 to 0.2 fx dx, you can apply the trapezoidal rule, which gives you f0 plus f1 divided by 2h plus f1 plus f2 divided by 2h, the values of further. And similarly, you have how many points you are having. So here it is f0, f1, f2, f3, f4, and f5. So total 6 points. So last one will be f4 plus f5 divided by 2h. So which gives you 1 by 2 and f0 plus 2f1 plus 2f2 plus 2f3 plus 2f4 plus f5 and times h. So that is the formula for your composite trapezoidal rule. Okay, is this clear? Okay, if it's clear, then you can try something. But first, I explain what is composite Simpson's rule. Then you can try one question based on that. Composite Simpson's rule. So if the question says Simpson's rule just only, then it means Simpson's 1/3 rule or Simpson's rule. All right. Okay. So what is the composite Simpson's 1/3 rule or Simpson's rule? That is very easy as well. So you just go with the Simpson's 1/3 rule that we have discussed before, that you already know. It's just about having 3 points instead of 2 points. That's behind the story. So here is the Simpson's 1/3 rule, which says h/3 for f0 plus 4f1 plus f2. So I just write here. So integration 0 to x0 to x2 fx dx is approximated as h/3 f0 plus 4f1 plus f2. Yes. So here 3 points are considered, x0, x1, and x2, where the distance is between h and this is h as well. So this is the Simpson's 1/3 rule. But if you gonna approximate your function over, again, it's the same way I explained 0 to 1, say, then you have 0.2, 0.4, 0.6, 0.8, and f0, f1, f2, f3, f4, f5. Then you apply Simpson rule over here, here. You cannot apply over here, so you just leave it blank. But if the question is saying, then you need to go till 1.2 to apply it. So it needs actually even number of points. So first, second, and third. Then you again will get the same kind of expression, which is 0 to 1 f dx approximated by h/3 f0 plus 4f1 plus 2f2 plus 4f3 plus 3f2 2f4 plus 4f5 plus f6. Yes. So that will be your composer Simpson's 1/3 rule or Simpson's 3. So I just suggest, just try to, okay, find value of integration 0 to 4 x dx using Simpson's 1/3 rule and composite since composite trapezoidal rule. With h is equal to 1 with the step size just try this and let me know the answer of this. I will also solve it. Then we go with more questions. Okay. Is that fine? Any doubts? I think someone is there. Yes, Deepa, you have.
No, sir.
Okay, all right. Just try this.
Sir, so answer is 8
Answer is 8 for
by both the methods.
by both the methods, is it?
Yes, sir. Actually, it is a linear, no, like function is in
Okay,
x,
so I
no, so
should
the,
then you should try for e to the power x maybe. That would be, yes, just try this.
So got the answer.
That anyone?
Yes, sir. By Simpson's one-third rule,
Okay.
the answer is 53.8638.
Okay, let me just 56.8638.
And by trapezoidal rule, just a minute, sir.
So the idea is like by Simpson's rule, you will be getting more accurate
Yes, sir.
answer. Yes, because the order of convergence is more, the more closer it will be. Yeah. So you can also, yes, so this is very clear, like 0 to 4 e to the power x dx. You have applied Simpson's rule over there. Then it's just how many points? 0, 1, 2, and 3, 4, right? So you calculated the value of e to the power 0, e to the power 1, e to the power 2, 3, 4, right?
Yes, sir.
Then you apply over here and here, first and second. Then you got this results. Is that clear to everyone? Okay.
So by trapezoidal rule, answer is I mean, it is 57.99.
It's 57.99. So which one is
Yes.
closer?
First one by Simpson's one-third rule, because by this actual integration, if we do it by formula, so it
Yeah.
is very close to that value, 53.59.
Yes. So that's the difference, and you have seen with the error as well. So another method that is nicer is the Simpson 3 by 8 rule. You can use this the same approach in that. So it's kind of same 1331, and then you will get. But I think in your books it's not allowed. It's not there. I think in your assignments, I would suggest. So there are some questions based on errors. Maybe I go with them. Okay. So one way is to calculate the error is using the exact and approximate solution. Other way is to use this numerical formula to find the error convergence. So this is the basically your error of convergence. So I just go there and show you. Okay. This is the error that you can see here. So I'm just giving you some questions based on that. And trapezoidal rule also you have already seen what is the error term in this. So I just go there. Yes, that's the error term, minus 1 by 12 h square f double dash psi. Okay, so I just say, just try to calculate the error of interpolation, error of approximating. So I just write some questions and try that. Okay, the error of approximating integration of 0 to 1 divided by 1 minus x dx. Oh, that's 1 plus x squared dx using composite Simpson's rule with n is equal to 4 is. So just try this one and another one. Use composite trapezoidal rule to calculate the error. So just try this and let me know what is the errors in this equation. Yeah, with an equal 4, of course. In this case, 0. Yes. Just keep some time over these and just look at the error if you want to see that. So why is this one? This is the error in this case, order of h square. Okay, if you remember, just remember it. Just look at it. Just try this.
Sir, do you have the answer of this question?
I don't have the answers, but I will show you how to do that. Just try by yourself. These are typical ones. So look at your assignment 11 and look the similar questions there and just try based on that and ask me any doubts related to.
Am I audible?
Yes, Nasir.
Sir, actually, coming to Simpsons, sir, okay, before the trapezoidal
Yeah.
composite, it's very clear how to go about the nodal points.
Hmm.
But coming to Simpson, the first problem what I am facing present, for example, in our assignment problem also, n is given as some 4, but they are asking to take us 2n plus 1. So I'm not able to understand how many intervals should we take for composite 1/3 or 3/8 rule. Can you just explain this, sir?
Okay, 2n plus 1 points with. Oh, they should mention like what is your capital N. It means like uh, for n equal 4 or something, then you just calculate what is capital N, right?
That's
So
for the
that
now.
required points.
Now, how to get that capital N?
Capital N is given in terms of small n. So small n is given and you can find capital N, right?
Can you just explain that? But this is not clear. This is where I'm getting confusion.
Okay. In the assignment, they have given you capital N to be 2n plus 1, right?
Yes.
So these are what they say as not points, right?
Okay.
So 2n plus 1 is basically 9 points, right?
Oh, okay. 9.
And
Okay. Here, capital. Now, here,
yes,
capital small n stands for number of intervals. Am I right?
small n stands for number of intervals, is it?
Yeah,
Wait.
because step size is given by b minus a by n, where n stands for number of
Okay.
intervals. No?
In your lecture notes, they use a small n for that.
Yeah, because now, for example, if we
Okay.
talk about trapezoidal also, uh,
Okay.
h
Understood.
is equal to b minus n, no? So if we
Yeah.
take
So
one
if it
simple
is then,
trapezoidal,
if n is 4, then it is 0, 1, 2, 3, 4, right?
3 and 4. So
Yes.
now
These
n will be
intervals.
number of intervals. Now what will be capital N? Now capital N we
Capital
have
N
got
is
9, no? So
9
is it
points. Yes.
a 9
1.
interval?
So that
Sir,
should be
now my doubt is now capital N will be number of intervals or the nodal points.
nodal points. That is
So
nodal.
it means we are going to have only 8 intervals for capital N.
Yes.
Okay.
Yeah. So 9 points. For me, for I've taken here n equal to 4, then it is just the intervals, and you have to use the interval points as nodal points. But here they have described it differently. Okay, that's a good thing. Just try this, and I have to go for 5 minutes. I will be back. Just try.
So, sir, sorry, Simpson's one third rule, the error which I am getting is 0.777, sorry, 0.0007 something. So, is that correct, or how to verify? Hello, hello, sir.
Yes.
Yes, sir, done. But I have a doubt, sir. So, can I ask?
Yeah, just give me 5 minutes. I will be.
Okay.
Sorry.
Hello.
Yes, sorry for delay. What is your doubt, Deepa? You want to ask?
Sir, I have obtained by Simpson's one-third rule the error I have obtained is 0.00074. But the problem is like
Did you
in
run
the
that? What was your approach?
so actually I have directly substituted values in that error formula.
What is that? So here is the error formula, right?
H to the
So,
power 5 divided by 90, that formula.
okay, for the trapezoidal rule, you have used this one.
No, so for Simpson's one-third rule, it is h to the power 5 by 90.
Okay.
So how to select that xi? I mean, xi value, xi should lie between somewhere between A and B.
Yes.
So actually,
So,
when we do it by trapezoidal rule, so the
yes.
second derivative value at 1 becomes completely 0. That means 0 error it gives. And when we
And-
are very close to 1, suppose 0.9 is chosen, so
Yeah.
then the error comes 0.4 times 0, like that.
Okay. So you just try to find out in terms of xi, then it would be good, and try to find out the upper bounds on the error. Yeah.
Okay, sir.
Yes. So
So for upper bound, we have to multiply it with n, no?
for upper bound, because it's composite, so you have to multiply by n, right? Yes.
Yes.
Okay. So what is the error formula in case of Simpson's rule? So the one thing I want to tell is the difference between that's so if I'm talking about Simpson's rule, that is basically truncation error, local truncation error, or truncation error. That is given by what is the formula you have in this. So that's just you copy here, -1 by 90 H5 F4 xi. So here is that F4 xi. So if I multiply by, oh, it is H4. And if you, so that is local and global truncation error. So if I'm talking about error in case of Simpson's composite, basically composite Simpson's rule. So in that case, the error will be this. Minus h cubed by 90 f4 I. So you basically multiply by n, this term multiply by n, and nh is, you can resolve it. So n is basically, nh is b minus a, and n is basically b minus a upon h. So that terms cancel out to give this kind of approximation in this case. And yes, so okay, it's h5. I forgot, I think something. Okay. So order of error is h5, so it should be h4. Sorry. Yes. So local means as compared to Simpson's rule, and composite as compared to composite Simpson's rule as compared to the global error here. So it's just what you, so here is composite Simpson's rule. So you need to use this kind of error, h4 divided by 90 f4 xi. So just try to calculate what is the fourth derivative of this function. This is your f. So that is your f, and calculate the fourth till fourth derivative and try to find out the error formula in terms of psi. Yes. If the question means is asking exact error, then just find the exact solution minus numerical solution. That is also error. This is absolute error. Is it clear? It depends on the question, what the question is asking. Any doubts? Okay, if this is clear, then it's good. So use composite trapezoidal rule to calculate the error, then you can always use the exact solution minus numerical and absolute value. Otherwise, if you need to find the bounds, then just use these formulas where f is defined. F is basically your this function over here, then you can use it. Okay, so we go on a new methods, basically, which is called as Gaussian quadrature formula. Okay, I just go with that. Let me see what type of questions you have. Okay, so what is the Gaussian quadrature formula is that, so you integrate your f of x from a to b, and you can write this into the two parts, a times f of x1 plus b times f of x2. And you use the polynomials in this way. So wait, I just use this here. Quadrature. Wait a second. I think that's not used before. All right, so just go with that one. Integration in terms of the values of the function at 2 points, linear combination of course, then you just take the two pairs of points, x1 f of x1 and x2 f of x2. You know the value of function at only 2 points. That's clear. So fx can be approximated by a polynomial. Okay. So you substitute this value. You take x1 to be 0 and x2 as h. Then you substitute values like px equal 1 for polynomial px 1. Then you find out what is the value of integration 0 to h px dx. Then you kind of solve this. So I just show you a working example over that, and we can see that. Okay, let me show maybe. Okay, I just say from here. Okay. So if your f of x is this and it starts from x minus 1 to x1, then you can write the value of function this integral as a times f at this point, first point, b times at second point, c time at third point. And then you assume that f of x is just a polynomial. So if it is a 1, if px is 1, then you just have these values a, b, c to be prescribed, and then you try to find out what is the value of minus h2h px dx. Then you got this as an equation, and you already know the integration. If px is x squared, then you get these values. So ultimately, you are getting a, b, c values from this solving this system of equations or this matrix. So I'm just getting that. So just try to do that and let me know with. So I'm just giving one question based on that, and we can try that. First, you try that, of course. Okay, so I just write similar to your assignment question. Even the quadrature formula minus 2 to 2 fx dx equals to c0 times f of minus 2 plus c1 times f of 0 plus c2 times f of 2. It is exact for polynomials of degree less than or equal to 2, then what are values of C0, C1, and C2. Okay, just try this one using the same approach. So you have to assume f is just a quadratic polynomial. You first assume f is 1, then 2, then 3, and then solve it. Just try this. Okay.
Excuse me, sir.
Yes.
Can you just go to the present slide, what you just showed?
This one?
No, yeah.
Okay.
Actually, even professor also went with the same, and even for assignment, I have got the values of C0, C1, C2. That's not a problem. Now, what my question is, since f of x is unknown, and coming to quadrature, the concept is if if you just try to have a similarity between Newton codes and quadrature. In Newton codes, we know the x values. Nothing but at which point we are thinking of finding those x values are known, but
Yeah.
in the x values are also unknown. That's a basic difference. Now, what my question is, can you just go back to the slide, sir?
Okay.
So after knowing the value, professor also found f of minus 2, f of 0, f of 2, and c0, c1, c2 value. Now here f of minus 2 we know, but f of minus 2, for example, here it is f at minus 2. But what is f at? How to get the value of f of minus 2?
How to get value of f of minus 2?
Yeah, let I just even because I have made a
That's
notes of that's we
that's
did.
that you don't know, of course.
Yeah, because f of x is not known to us.
Yes. So you
So
don't know.
just
So it's kind of giving you the formula for, you know, what the trapezoidal rule you have seen, right? Simpson rule. So it's kind of giving you the exact formula for that. It's just a derivation. And if you want to describe your function in terms of the points of the function in between, and like in the trapezoidal rule, you want to ask like how the h by 2 is coming in that. So that's because coming from quadrature formula, or you can derive from something else. So finding the correct coefficients in terms of function values, it should be the goal.
okay.
Yes.
Thank you.
So you already found out these values. Just
Only
try.
problem I have is last problem, because
Yeah.
in last problem I've been given the function. So now the present concept which you have taken is function is not known, due to
Yeah.
which f of we are assuming as x power 0, x power 1, x power 2.
Yes.
But for the last problem, function is given. So how to go about that is a question mark.
So if function is given, then you know the values of the function at these points, right?
So we are not going to think of approximating to f of x as x power r for 10th problem.
No. Means you are already taking the help of the polynomials. That's true.
Sorry?
Because every continuous function can be approximated by a sequence of polynomials.
That's what, sir. Now for 10th problem, are we going to approximate? Because for 10th problem, a very easy function sine is given.
Yeah. So in that case, how would you find out? That's question.
No, that's what the problem. Now the problem is, should I take f of x as x power r again and try to approximate, or
Yeah, question in the 10th question, I think they have not given you that it is exact for all polynomials for all degree less than equal to 2.
yeah,
So if
nothing is said.
yeah,
Only thing
if
is,
it is not
what
given,
is
then
the
use the
value
same function.
using the two terms of Gaussian quadrature. By using two terms of Gaussian quadrature, what is
Let me
the
show which one is the formula for. Yeah, so this is the two-term Gaussian quadrature formula. Okay. A times some function value and B times some function value, right?
yeah, and one more thing is whatever professor went for, it was in the interval -1 to 1, but here the interval is 0 to pi by 2. Are we going to have any
You will
linear
also
time?
see that this two-term integration formula reduces to the trapezoidal rule. So you can use trapezoidal rule in this case. Yeah.
So 2 point form, we reduce to trapezoidal in general.
Yes, just use
Okay.
that.
So can you just upload this material for us so that we
Yeah,
can also take for reference?
the book you are saying?
Yeah, the book one, the book which
Book
you
has,
are.
oh, I also uploaded the book before. Have you seen that?
Sorry, sir.
I have uploaded that before.
Oh, is it? Okay, then I will just go through it, sir.
Uh,
That book,
I
the book is same as
will
the
share
one which
this.
you are referring.
Yeah,
The book, the one which you are referring presently is the same book.
it's the same applied numerical analysis by Wheatley. Yeah, it's the same. Yeah.
Okay, thank you. So it is the same as now trapezoidal itself.
MK Jan is different one. The two books, but MK Jan I haven't uploaded on the Drive link. So for this part, this book is good. Girard Wheatley numerical analysis.
To be great help for us also. So it means I can go with trapezoidal itself then.
Yeah.
Ultimately, it reduces to trapezoidal.
Yeah.
So in that case, the step size will be 1.
Yes. In this case, what is that? To see. It should be step size should be pi by 2. But here in in this question that I'm giving similar to, then you just use the step size to be 2 in this case. So just try that and find these coefficients. I want the coefficients. Okay, have you done this? What are the values you are getting? Okay, so this is minus 2 to 2 fx dx, and you have polynomials. So fx is given as ax squared plus bx plus c. So as a first step, you try to calculate fx at a, fx bx equals to 1, case 1. Then you substitute it here, then minus 2 to 2, 1 dx, which is same as, if you have to find out the coefficient c0 plus c1 plus c2, because all over the values will be same. And that will be your 1, 2 plus 2 divided by 2, that is 2. So first equation is this, case 2, fx is approximated by bx is equal to 2. Sorry, it is should be x square. It's not x square, it should be x. So in this case, bx is x. Then you have minus 2 to 2, x dx will be same as minus 2x plus 0 plus 2x. What happening? It is c0 and c2. So that's, this will be, should be x squared by 2, and that would be 0, and which is c0 plus c0 minus c2 is 0. And case third is that x should be identically same as px x squared. So minus 2 to 2 x squared dx, which is same as 4c0 plus 0 and again 4c2. So that will give you x cubed by 3. So 8 by 3, so 16 by 3 equals to c0 plus c2. So that will be your 4 by 3. So you have kind of 3 equations now, 1, 2, and 3. You can solve 1, 2, 3. To get c0, c1, c2, and then you have this kind of. So once you have c0, c1, c2, that's true. That you have to find. Okay, is this clear? Any doubts? Any questions?
Sir, C1,
Yes.
C0 and C2 value is 2 by 3.
So c0 and c2 are 2 by 3. Is this correct? Yes. Okay. And what is c1?
Even I got 8 by 3, sir.
Okay. That's right. So similar type of questions will be asked in your exam. So just prepare accordingly. And I want to let you know that we have extra tutorial session on 10th of April. I think you have got the notification on 10th of April from 6 p.m. to 8 p.m. this Thursday. Okay. Just attend that, and after that there will be a last session next week on Monday, same time. So only 2 sessions left, and come up with the questions. I want questions next time more. So if you have any problems before your exam, just let me know, and just try some other, because on 10th of April, I will be taking the tutorial session compromising pricing of all the doubts from your sides as well, and some questions from my side as well, from whatever we have done so far from for exam point of view. Okay, so just come up with the questions.
Sir,
Yes,
actually, I mean, this course name is Scientific Computations using Matlab, but it's more about numerical methods and less about Matlab. So why it is so?
that you should ask to course coordinators.
Because we were told that I mean, we'll get access to Matlab, everything, but
Because
when we
you know,
still not,
you can
Matlab was
implement,
stopped.
yeah, course name is such a way so that you can always implement these methods in MATLAB. That's true.
Yes.
But for exam point of view, yes, MATLAB is not needed as such. But yeah,
I mean, we won't only the the question type of questions which we were asked in assignments. Only those questions will come related to MATLAB, no? Like only the syntax of this and that. Those questions will only be asked.
yeah.
And will not be. I mean, it will not be expected from us to do something in MATLAB.
No, there's no
And so
nothing.
calcs, they have said that you can't carry your physical calculators, or but those
Yeah,
screen calculators, they are very slow. I mean, these are faster than those virtual calculators. So last time also, students they faced problem with those scientific virtual calculators. So then the notification came that okay, you are allowed to carry calculators. So, but this time they have not issued any such notice yet.
so you can take the calculators.
Physical calculators are not allowed. We just received one message on that.
Okay.
But scientific calculators, they don't work efficiently. I mean, we do not have much practice on working with virtual calculators. So they
Right.
should allow us to carry the physical calculators. I mean, non-programmable calculators.
Just send them an email.
Okay, sir.
Yeah, you can note. Any other queries?
So, sir, this 10th of April, it's a doubt clearing session, no? Like, only doubts will be discussed. No queries related to assignment number 12.
No, you can ask. Yes, assignment number 12 will not be discussed.
Okay.
Before that, we can discuss.
Okay. So, all like 1 to 11 assignments. And so, the
Yes,
solutions which they gave, they only gave the answer key. I mean, the full detailed solutions they haven't provided on assignment for us of assignments.
answer them. Yeah. I will say to the professor, which assignment you are saying?
Some solutions they have uploaded, no, like assignment number 1 to 9, probably solutions of 1 to 9 assignment they
Not
have been
detailed.
uploaded. But they're, I mean, they're not solutions, only the answer keys. I mean, answer of this question is A, B, C, D is like that.
No, but some said like detailed solutions are also provided, right? Have you not
No,
received it?
no, sir.
Nasir and others, have you received, Rakshita?
Sir, few questions only have full answers.
Few questions. Okay. Means not every question has full answer, you are saying. Okay. Okay, I will ask to upload full solutions from the professor and then again do.
Hello, sir.
Yes.
Sir, will they offer internship to the post toppers?
I don't know about it. You can just email the professor who's
I
teaching
mean,
the course.
in past, or like, if you have any idea in past, did they offer any such internship?
I don't know about this. Sorry. But,
Okay, sir.
but if you say you got good grades and all, then they will take you in if they are interested.
Yes, sir. Actually, last year in winter, like I had the internship from at IIT Kharagpur in linear
Okay.
algebra. It was yes.
Okay, so you have done a project.
No, so actually I had rescheduled it because I had exam during that period. So now in summer I'll be doing that internship. And
Oh,
in last, I mean, in this winter also, I mean, I have a chance of getting internship, another internship, because I was a topper in engineering mathematics course.
okay, okay, that's nice. So you can
I was
contact the professor.
wondering, even if they offer internship, so it can't be
You are asking
virtual.
about paid or unpaid internships.
Uh, yes, pardon, sir.
Paid internships or unpaid?
So actually, I opted for virtual. So for virtual, like they don't give any
Okay,
payment.
okay.
Hmm. And this time they have increased the internship in uh, the amount of internship, like the per month salary, you
As
can say.
such, if you just approach a professor and say that I want to work in one of your project, then she won't deny. So you can work in summer or winter, yes, if they want to.
Okay, sir.
Yeah. Yeah, I just stopped the session. Thank you very much. See you on 10th April.
Thank you, sir.